Lesson 2-4. Label your homework notebook properly. We have just one vocabulary word. I think this is the first one for this unit. That's nice. An identity, and of course this is a math definition, not a regular definition. An identity is an equation that is always, always true, no matter what you put in for your variable. For example, y plus 3 is always going to equal 3 plus y, no matter what y is. Get that written down. I'm looking at page 102. I can't believe we're up past 100 pages already. The next step in our process, it's a baby step, solving an equation with variables on both sides. What happens, for example, we've got 5x plus 2 equals 2x plus 14. Well, using what you already know, I bet some of you, maybe Narissa, have figured out we need to combine the like terms. How do we combine 5x and 2x? Well, we're going to subtract 2x from each side of the equation. And they work you through this right here. 5x plus 2 minus 2x. That's a little hard to see. That's better. 5x plus 2 minus 2x equals 2x plus 14 minus 2x. Remember, we can do anything to an equation as long as we do the same thing to both sides. So combine the like terms. You get 3x plus 2 equals 14. Then you need to get the numbers combined. So we're going to subtract 2 from each side. 3x plus 2 minus 2 equals 14 minus 2. Results in 3x equals 12. Divide each side by 3. X equals 4. Done! That was not so bad. Take a look at Got It Problem 1. One of the things I'm trying to show you with these videos is what I expect your work to look like. Starting with your Unit 2 test, neatness is going to count on your test grade. So I'm showing you a couple of options. First, number, letter, because it's a 1A, write out the equation. Then, for my first step, I decided to subtract 4k from each side. That gives us 3k plus 2 equals negative 10. The next step is to subtract 2 from each side. 3k equals negative 12, divide by 3, k equals negative 4. I understand that some of you maybe don't need to think this through with all of these steps. So I am going to give you some options. This is a more minimum but still acceptable number of steps. Same problem, 7k plus 2 equals 4k minus 10. If you are thinking through in your head, well duh, 7k minus 4k is 3k. 3k plus 2 equals negative 10. That's fine. I want to see this step. And then again, if you subtract 2 from each side in your head, I want to see the step, 3k equals negative 12. Divide each side by 3, k equals 4. This is the minimum number of steps that I want written out to solve an equation like this. Also, notice that I have written each of these one below the other. One of the things that happens is at the very bottom I can see, oh, k equals negative 4. Makes it very clear what your answer is and how you got there. Letter B uses the same problem that we already did in the book for the example. 5x plus 12 equals 2x plus 14. And the question is, what happens if you solve it by subtracting 5x from each side instead of subtracting 2x from each side? And before you go any farther, I want you to think about it. What's going to happen if you start by subtracting 5x from each side instead of subtracting 2x from each side? All right, I know you've got your answers. Let's go ahead and test out what you thought. So, I've got all the steps written out. Subtract 5x from each side, so we end up with 2 equals negative 3x plus 14. 2 minus 14, negative 3x plus 14 minus 14, negative 12 equals negative 3x, divide each side by negative 3, x equals 4. exactly the same answer. We just combined like terms in a different way. That is just fine. And again, let me show you, if you didn't want to write out every single one of these steps, I need to see this step right here. I need to see this step right here. And I need to see your answer in a problem properly written out, nice and neat. So I'll be honest with you, often these problems like problem 2, they're trying hard to give you a practical example of where you might use your algebra skills, but sometimes I think they're kind of confusing. But this particular problem too, I really, really like because of this model right over here. So let's take a look at this problem and figure out why I like it so much. It takes a graphic designer 1.5 hours to make one page of a website. Using new software, each page will be done faster, but it takes 8 hours to learn the software. How many pages would the designer have to make in order to make it worthwhile to use the new software? And then you've seen this many times before. These are the things you know, these are the things you need to know, and this is what you're trying to do. You're trying to write and solve an equation that figures this out. And then they start to turn this into words to turn into an equation. You need to relate the current design time, which is 1.5 hours a page, to the design time with the new software, which is only 1.25 hours a page. But you need to take into consideration the time to make the software. And I read all that and I sort of went, I'm a little confused. But then I saw this model and it made it so much clearer. So here's what we've got now. 1.5 hours for each page that needs to get uploaded. Using the new software, only 1.25 hours times each page that needs to get loaded, but we have to add in that 8 hours. Oh, now all of a sudden it makes sense. We're trying to see at what point this is equal to this so that we know when it becomes advantageous to use the new software. So you work through the equation and you figure out P equals 32. Okay, that's all well and good, but what does that mean? It means that when you have 32 pages, 1.5p is equal to 1.25p plus 8. So if you have to make 33 or more pages, it makes more sense to learn the software. If you only have to make 31 or fewer pages, it makes more sense to do it the old way. You're going to have to actually look in your book on the bottom of page 103 for the problem. Got it number 2, you can use exactly the same model that they used in their example. We're just going to substitute in the different numbers. This is a problem about whether or not you should purchase an energy-saving copier. It's $650 for the new copier. The electric bill will go from $112 to $88. How many months does it take the copier to pay itself off? So we're trying to find months, so let M equal months to pay for the copier. And then your equation is going to look like this. And I just substituted exactly from the first one. The original electric bill times months equals the new electric bill times months plus the cost for the new copier. 24M equals 650. Divide each side by 24. And I'll know here if you're using your calculator or your brain if you come up with some kind of long, ugly decimal. M equals a little over 27 months. So during the 27th month, the copier pays for itself. This becomes equal. So if you're going to keep the copier for more than 27 months, it makes sense to buy the new one. If you're going to keep the copier for less than 27 months, you might as well stick with the old one. Problem 3. I really don't know why they didn't call this solving an equation using the distributive property, but they didn't. So I'm going to walk through it simply because this caused people a little bit of trouble on the last test. If you're going to solve this, yes, everybody gets multiply 2 times 5x, but don't forget to multiply 2 times -1 as well. So you end up with 10x minus 2. And on this side, 3 times x, which is 3x, but also 3 times 11, which is 33. Then you're going to combine like terms, get them all on the same side of the equation, so you end up with 7x and 35 over here, and x is going to be equal to 5. Now we are up to problem 3a on page 104. Copy it down, and I want you to work on it on your own. Pause the video, then we'll come back and quick check it. I'm going to go back to my Rubik's Cube. Alright, I got one side done, and I bet you guys got this problem done in the meantime. So, remember, we are distributing this 4, multiplying it by 2y, also multiplying it by 1, distributing this 2, multiplying y by 2, multiplying -13 by 2. And here's your first step. Notice I put a star next to it. That means I expect everybody has that step written down. Then there's the intermediate step, where you subtract 2y from each side. The next step, it's got a star. I expect everyone has this written down. Step after that, again, you might have it written down or you might not. The next step, I expect everybody has. Divide by 6, y equals -5. Again, obviously, I expect everyone to have it. So, in case you're confused, I expect you to have at least every line with a star written down in your notebook. If you have these additional lines, that is just fine. But one of the things we're focusing on now is keeping your homework neat, keeping your work neat so that it's easy to find your answer. I want to make sure you're all clear on how to do that. Go on to letter B. I am going to get a second side done. Well, I'm stuck again. I got another side done, but then of course I lost my yellow, so clearly more practice than that. Going back to math, which I'm much better at. Letter B, I did the same thing. In case you haven't gathered by now, my focus here is on what this math should look like in your book, almost as much as you finding the right answer. So you're going to distribute the 7 on this side, you're going to distribute the 3 on this side, and what you should end up with looks like this. Put a star next to it because I expect to see this step in your work. Next step, I chose to get all the A terms on the same side first. This step, again, I should see 28 equals 10a minus 12. Then I combine the numbers without variables. 40 equals 10a, divide by 10, 4 equals a. Now, you may be asking, but Margaret, what if I decided way back here to combine the numbers first and not the 7a's? That's fine. The point is, show what you end up with on the next step. So if you did, if you added 12 to each side first, then you should have something that looks kind of like 40 minus 7a equals 3a, and you would proceed from there. So my focus is, are you putting the steps in order? Problem 4 brings in our vocabulary word, identity. Take a look at letter A. After you simplify this side, you end up with 10x plus 12 on one side equals 10x plus 12 on the other side. This is called an identity. No matter what you use for x, it will be correct. Now, letter B, as you take a look at it, that makes it easier to take a look at. You combine like terms, you simplify, you end up with -4 equals 5, which is not true. So this equation has no solution. You might ask, but then Margaret, why did they give it to us? I don't know. I can't tell you. But they want you to be able to figure out if the equations have no solution. And that is your job in Got It number 4. Put these in your book, practice writing them neatly the way I asked you to do, and then check your answers against mine when you're done. I'm going to take one more stab at this. All right, making progress. I have this side all solved and I have corners in place. It's getting better. Still not very good though. Letter A should look kind of like this. You've got the equation written out. Start working through the steps. Notice that I still have stars on the things that I expect to see. -2 does not equal -6. So there's no solution, or I should say letter A has no solution. Letter B. Write out your equation. Okay. Oh, looks like I forgot to put in stars on this one. I do want to see this step because it involved distributing. I don't need to see that second step. I do need to see this third step. 7 does not equal -3, so again, this equation has no solution. And now what you've all been eagerly waiting for, your homework. Again, I'm going to give you choices. If you want the more straightforward problems, because you just think you need some extra practice, do 11 through 31 odd on pages 105 to 106. If what happened in this video seems really simple to you, then try the problems where you're applying the math a little more. 33 to 49 odd, page 107 to 108. We'll check them in the next class.